This will be for the con assignment, calculating the equation of the least squares line. Okay, most of these you don't have to read the write-up. I'll just read this one. A personal trainer wants to look at the relationship between number of hours of exercise per week and resting heart rate of her clients. The data show a linear pattern with the summary statistics shown below. All right, so here's a summary of the statistics. The x-axis is hours of exercise per week. Y is the resting heart rate. Okay, and I'm just going to write an interpretation of these variables real quick. All right, so just to get this out of the way first, if you recall from a previous exercise, R is our correlation coefficient. Okay, that's one of the exercises in this unit. Anyhow, we remember from the past, the population mean is usually represented by the Greek letter mu, and the population standard deviation is represented by the Greek letter sigma. Okay, now in this case, we're just dealing with the sample. All right, so for the sample mean, that's going to be X bar. Okay, or in the case of the Y's, or the y-axis, it's going to be y bar. All right, and for standard deviation, it's just defined with an S. Okay, for the sample standard deviation. Now, if it's the sample for the x's, they just write S sub x. If it's the sample for the y's, they just write S sub y. All right, so I just wanted to outline that so you're not confused. The reason we're not using mu and sigma is because we're not dealing with a population, we're only dealing with a sample. Anyhow, given this data, we basically want to write the line equation. Okay, it says find the equation of least squares regression line, fancy name, for predicting resting heart rate from the hours of exercise per week. So basically, this is just a line equation, y equals mx plus b. Okay, the only difference is it's in the form of y equals b plus mx. All right, not sure why they do that, but nevertheless, we're just writing the line equation. Okay, so in order to find m, the slope, the formula for that is going to be R, which is the correlation coefficient, times the standard deviation for the y divided by the standard deviation for the x's. All right. Now, if it helps, I'll write it differently because we know this number R is just really in the numerator. So you can say it's R times the standard deviations for the y divided by the standard deviations for the x's. Okay, so this is going to be the formula for slope m, which goes in this box right here. And we're going to round to the nearest hundredth, which is 2 decimal places. Let's look at our data chart again. Okay, so let's see. It says R is negative 0.88. All right, so let me plug that in right here. All right, in place of R, negative 0.88. Okay, and now for S sub Y, we have 7.2. All right, so in place of S sub Y, I'm going to plug in 7.2. And that's divided by S sub X. For S sub X, we have 4.8. All right. Okay, so I'm going to do this on the calculator. All right, and I got negative 1.32. I did not have to round. It came out to 2 decimals in the first place, so I don't have to round to the nearest hundredth. So this number is the slope m. And as we know, m is the number multiplied by x in the line equation. So that goes right in this box. Whoops. That goes right in this box here, negative 1.32. All right, and now we have to solve for the Y-intercept B. I'm going to show you how to do that. Okay, so what you want to do in order to solve for B, you want to plug in X bar and Y bar. All right, because this coordinate here, these coordinates are one of the points on the line. Okay, so if you plug this in here, you can solve for B. So let's do that. X bar is 8.9 and Y bar is 74.3. Okay, so that's 8.9 and 74.3. Okay, I obtained those numbers from the data chart. All right, it has X bar and Y bar in the chart right here, 8.9 and 74.3. So we're going to plug that in and solve for B. Okay, so the Y value is 74.3. And that's going to equal the Y-intercept B plus negative 1.32 times X. We're plugging in 8.9 in place of X. All right. So let's see. All right. So I'm going to do this part on the calculator. I have 74.3, and that equals B. And I'm going to multiply these two on the calculator. Okay, and I get negative 11.748. In order to solve for B, I'm just going to add this to both sides. So plus 11.748 plus 11.748. Okay, it cancels right here. And I'll do this on the calculator. And I get 86.048. Okay, I just added these two numbers. Now it says round to the nearest hundredth. All right, so you look at the third decimal. Since this is 5 or more, we're going to round it up. So this 86.04 is going to become 86.05. And just enter that in the box for B, 86.05. All right, so remember, you can always do the algebra first. All right, since our equation is in the form of y equals mx plus b, you can solve for b by subtracting mx on both sides. So you can do this before you plug anything in, and you can say that y minus mx equals b. All right, so I'm going to do that on the next problem. In order to solve for b, I'm just going to do y minus mx and plug it in right there. We'll do that on the next one. Okay, so I'm pretty sure for all of these, you don't need to read the write-up. All right, they give you the mean and standard deviation and correlation coefficient, and you just need to write the line equation and round to the nearest hundredth. All right, so remember our line equation. It's in the form of y equals b plus mx. All right, m is the number multiplied by x. That's the slope. Okay, we said the formula a minute ago was correlation coefficient r times sy divided by sx. Okay, please write this formula down. And for r, we have 0.95. All right. You can write 0.95 or just 0.95. It doesn't matter. For SY, standard deviation of Y, we have 4.6. So in place of SY, it's a 4.6. And for SX, we have 2.3. So in place of SX, I did 2.3. Going to do this on the calculator. And I get 1.9. Okay, I did not round off. That's exactly what I got. That is our slope M. M is the number times X, so you enter 1.9 in the box next to the X. Okay. Now, of course, we're not finished yet. We have to solve for B. All right, remember, the equation is y equals mx plus b. And if we solve for b, we do a minus mx on both sides. And it cancels here. So y minus mx equals b. Okay? But remember, we're plugging in x bar, comma, y bar. Okay? Because that point is on the line. So in place of y, I can write y bar. In place of m, I can write, I'll just leave m for now. And in place of x, I can put x bar. So b is going to be y bar minus m times x bar. All right, you can write this formula down as well. So for y bar, you go to the chart. Y bar is 33.6. For m, we did it before. That's a 1.9. And for x bar, you go to the chart. That's a 41. And that equals B. Okay, all you have to do is do this on the calculator. Okay, doing this on the calculator, I get negative 44.6. All right, that's B, or the Y-intercept. So you just put that in the box. All right, negative 44.6. And we did our slope already. Okay, we don't need to round in this case. It was already rounded off. Whoops, let me see what I did wrong. Okay, I just made a small typo. That's what it was. Y bar was 33.6. I accidentally plugged in 33.3. Okay, but everything else I did was correct. I just wrote it wrong. So let me redo this on the calculator. Okay, and this time I got negative 44.3 instead of negative 44.6. So just a little typo right there, 44.3. All right, so that's it. And I just want to mention one thing. If you check their answers, okay, they label it a little bit differently. I did the standard line equation y equals mx plus b, or you can say b plus mx. Okay, but they use different letters or coefficients because it's a line of best fit. It's not an actual line. So instead of b, they used a, and instead of m, they used b. Okay. It's a little annoying that they did that because usually we think of B as the Y-intercept, but this is the equation for line of best fit. All right, so if you look at their answer, just make a note of that so you're not confused. In their case, B is the slope and A is the Y-intercept, but I did it the standard way.